So today, we're going to dive into a really fascinating clash in the world of science communication. It all kicked off with a viral article by one expert, Dr. Vinay Prasad, that then sparked this massive evidence-based response from another scientist, Dr. Casey Husser. And that really gets to the heart of what we're exploring here. I mean, what happens when someone with impressive credentials, someone with MD after their name, makes an argument that sounds really compelling? It's so easy to believe, right? But what if that whole argument is built on a really shaky foundation? How do we, just regular people trying to stay informed, tell the difference? So the way we're going to tackle this is by treating it like a case study. We're going to follow along with Dr. Husser's investigation as he fact-checks and kind of deconstructs the claims in Dr. Prasad's article. And along the way, we'll see how to spot these logical errors and misleading arguments for ourselves. Okay, so first up, let's take a look at the article that started this whole thing. Dr. Prasad put forward what he called a simple litmus test for figuring out which public health ideas are worth considering. The whole idea is actually pretty simple, and you can see why it's appealing. If a policy is being used over in Europe, then it should be seen as a reasonable option for the US. It sounds worldly, it sounds smart. But, according to Dr. Husser, this is exactly where things start to get a little shaky. So let's put this litmus test under the microscope, shall we? Does it actually stand up to a little bit of pressure? Well, Dr. Husser argues that its basic logic is deeply flawed, and here's why. What Dr. Husser points out is that this whole argument is built on a classic logical fallacy. It's called the envy fallacy. The argument isn't based on scientific evidence, a careful weighing of risks and benefits. Nope. It's based on wanting something just because someone else has it. Put simply, just because a policy works somewhere else doesn't automatically mean it's a good idea here. And this is where that logic totally falls apart. I mean, think about it. If we just blindly followed the Europe does it rule, we'd also have to consider policies that are completely at odds with American culture, like banning camouflage in public. Husser's point is crystal clear. Laws and policies are shaped by culture, by history, by all sorts of unique circumstances, not just by some universal scientific truth. All right, let's dig into our first case study to see this flawed logic in action. Dr. Prasad uses his litmus test to argue that we should relax the rules on selling raw, unpasteurized milk. Let's see how Dr. Husser breaks this one down. This is just a perfect example of how framing can completely change how we feel about risk. Look, both of these statements are statistically correct. Neither one is a lie. But feel the difference in how they land. 7 in 100,000 sounds pretty tiny, right? Almost like no big deal. But 840 times more illnesses? That sounds terrifying. This shows just how easily stats can be manipulated to support a story without ever being factually wrong. And this is where Husser points out what he calls a pretty major inconsistency. So on one hand, Dr. Prasad is okay with the risk from raw milk, which causes about 7 cases of illness for every 100,000 people. But on the other hand, he's very worried about vaccine-mediated myocarditis, which has a lower risk of about 2 cases per 100,000. Think about that for a second. It's a clear contradiction, right? Fearing a smaller risk while actively encouraging a bigger one. All right, let's move on to our next case file, because this pattern of selective framing doesn't stop there. This one tackles one of the most heated topics from the past few years, COVID-19 vaccines, especially when it comes to kids. Okay, so the argument against vaccinating kids often zeroes in on this one known, though pretty rare, side effect, a slightly increased risk of myocarditis, which is an inflammation of the heart muscle in adolescent boys after they get an mRNA vaccine. This specific harm is what's often highlighted. But, and this is a huge but, this chart shows the critical context that Dr. Husser says is almost always left out of the conversation. Yes, there's a risk from the vaccine, but what about the risk from the virus itself? Well, the risk of getting myocarditis from a COVID-19 infection is over 10 times higher for that exact same group of teenage boys. When you leave that part out, you're not just omitting a detail, you're completely changing the entire risk-benefit picture. And here we go again, another example of how your choice of comparison is everything. Prasad compares the US to Sweden to try and show that strict lockdown measures didn't work. But as Husser points out, that's a total apples to oranges comparison. The US and Sweden they're wildly different countries. A much better, more scientific comparison? Sweden versus its neighbor, Norway, which is culturally very similar but had stricter rules. And what does that comparison show? Sweden had 10 times higher mortality. A very different story. So after digging into these specific case studies, let's pull back and look at the bigger picture here. What's the real lesson about the nature of misinformation itself? Well, Dr. Husser argues that this whole episode reveals a fundamental imbalance in the way we share and consume information.
This brings us to a really important concept known as Brandolini's Law, or as it's sometimes called, the bullshit asymmetry principle. And it's simple, really. It is way, way easier to make a mess than it is to clean it up. It takes almost no effort to create a simple, catchy, but totally misleading claim. But the hard, thankless work of tracking down all the evidence to carefully debunk it, that takes a massive amount of effort. And you want to see a perfect picture of that law in action? Here it is. Dr. Prasad's original article, about 2,300 words. Dr. Husser's super detailed point-by-point takedown, over 9,000 words. It took almost 4 times the effort just to set the record straight, which really shows the huge challenge that scientists and fact-checkers are up against every single day.
And that really brings us to this powerful quote from Dr. Husser, which kind of gets to the heart of his entire argument. He's basically saying the scientific community can't just sit on the sidelines when misinformation is spreading, especially when it's coming from one of their own. He admits the work is exhausting, but letting sensationalism win is way, way more dangerous in the long run. Which, of course, leaves us with a big, critical question. When we're faced with 2 credentialed experts telling us 2 completely different things, how do we figure out what's true? As we've seen today, it's not about just picking a side. It's about always looking for the full story, questioning how information is framed, and remembering that simple claims often hide a ton of complexity. And those critical thinking skills are something we all need now more than ever.